Hello everyone, I am Ranjana Venugopal, PhD researcher working under the supervision of Dr. Vishwapriya Dev at the Center for Sustainable Energy Technologies, CSIR NIIST, India. We are the Smart Materials and Devices group, and our research is focused on energy materials, stimuli responsive materials, dynamic windows, thermoelectricity, and photovoltaics. I am pleased to discuss the research work published recently in RSC Applied Interfaces titled Electrochromic Properties of MnO2W3 bilayered electrodes for Enhanced Charge Storage and Superior Stability.
Electrochromic systems are great examples of active chromogenic glasses in which the optical throughput may be adjusted to the user's preference by modulating the electric voltage input. An electrochromic device or an ECD is a multi-layered sandwich cell system comprising an active layer, an electrolyte layer, and a charge balancing counter layer positioned between two conducting glass plates. Through electrically driven ion insertion or extraction from the electrolyte, the system orchestrates a reversible redox reaction in the active and counter electrode. Devices based on these materials are making inroads into the global market as energy-saving smart windows, facades, privacy-controlled glasses, and so on. This study employs a bilayer structure consisting of an ultra-thin layer of MnO2 coated with W3 as the active electrode. In addition to a strong optical contrast, adding a thin functional buffer layer to the electrochromic transition metal oxides improves the electrochemical stability and charge storage capacity of the ECD significantly. This dual functionality could then be utilized for smart window applications involving energy storage. MnO2 possesses practical advantages due to its exceptional electrochemical stability and wide potential range. The electrochromic and storage performance of both amorphous and crystalline phases of the W3, which were coated with MnO2, were investigated using a trivalent aluminum ion containing gel electrolyte. The MnO2W3 bilayer was created using a mix of salt gel and electrochemical methods. The films were then characterized using XRD, SEM-EDS, FTER, Raman and XPS studies which confirmed the presence of MnO2 on W3. The charge storage capacities of the electrodes were investigated by cyclic voltammetry. An appreciable rise in the current density values was noted in the films following the application of MnO2 overcoating, demonstrating the improved ability of the active electrode to store charges. Such enhancement can be attributed to the increase in surface area, resulting in more active electrochemical sites. Additionally, the creation of heterojunctions also contributes to the activation energy for ion intercalation-deintercalation. Based on the power law dependence equations, we found that the electrode composition exhibits pseudo-capacity or battery-like behavior, with diffusion-controlled processes being the dominant factor. In addition, electrochromic performance assessments were conducted on 4 different devices fabricated with the designed electrodes. MnO2 overcoating improved the coloration efficiency of the electrochromic devices for both amorphous and crystalline phases, with the amorphous phase displaying greater coloration efficiency. A lower coloration efficiency value means more stored charges are required for the same change in optical density, thereby making the crystalline phase better for simultaneous electrochromic as well as charge storage performances. Furthermore, the bilayered electrodes demonstrated exceptional stability across 200 cycles with virtually no reduction in optical transmittance contrast. The MnO2 overcoating forms a barrier between the W3 films and the electrolyte and reduces the interfacial activation energy for charge transfer, enhancing the electrochemical stability. In closing, I'd like to acknowledge the co-authors for their help in carrying out this research. Their efforts were instrumental for exploring electrochemical pathways to simultaneously improve electrochromic response and storage capacity, which is essential for achieving optimal energy saving in smart windows. Thank you.